Well, hello again. As exciting as the law of sines was, sometimes you cannot use the law of sines, and hence we have another law to talk about, the law of cosines. So here's what we're going to be talking about today, and that's to be able to solve triangles. And you're going to use a combo of the law of sines to find missing sides and angles and the law of cosines. So let's take a look at what we got going. When can you not use the law of sines to solve a triangle? When you're given two sides and then included angle. It might be known as side angle side. So if you have these two sides and this angle, there's no way to use the law of sines to solve a triangle. Or if you're given all three sides of the triangles and no angle at all. So in these two cases, you need something else. And that something else is, oh yes, the law of cosines. So the law of cosines comes in three formats. You've got a squared equals b squared plus c squared minus 2bc cosine of a. If you notice, your lowercase a, your side a, and your angle a are the same, and then the other two sides are in here. So that might help you kind of memorize the law of cosines a little bit. B squared is the other one. Notice you got the b, little b over here and the capital B over here. Then you got a squared, c squared, minus 2ac. Big thing to remember on doing this one is to watch your signs. So the third form of the law of cosines would be c squared equals a squared plus b squared minus 2ab cosine c. Notice little c, a big C over here. Let's see. Don't you want to know how it works? Oh yeah. So solve for this triangle. Give the lengths to the nearest tenth. Give the measure of the angles to the nearest 10 minutes. So if we've got little b, little c, and angle A. So little b, little c, and angle A. That's side angle side. I like to put the measurements in here. It just is easier. And we're going to use law of cosines to at least find one side. So let's say I want to find the side A that's opposite of the angle. Then here's the two adjacent sides, the sides that form angle A, and I can plug and chug those right into the formula. So I'd have a squared, little b is 7, little c is 10. So it's going to be a squared equals 7 squared plus 10 squared minus 2 times 7 times 10 times the cosine of 51. When you do this all out, you crunch those numbers. I would go ahead and put them straight into the calculator. So we end up with a squared equaling 60 point la 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 la. I leave the whole big honkin' thing in that calculator and then just take the square root of both sides. So we're going to take the square root of this side, square root of that side. Opposite of squaring is rooting. And if you do that, you get a is approximately 7.8. Bada boom, bada bing. And we're very happy. Now, to find angle B and angle C, we can use the law of sines to find that. So if I want the angle B, I don't know this angle, but I know this side, and I have this side and this angle here and the opposite side. So once I have a side and the angle that's opposite of it, I can use the law of sines to find a missing side. So I'm going to use little a over sine A equals little b over sine B. Plug in what you know. 7.8 over the sine of 51 equals 7 over the sine of b. Remember to multiply diagonally of the 7 and the sine of 51 and then divide by the third number. So you end up with 7 times the sine of 51 over 7.8 equals the sine of b. Do you remember how to find the angle if you know what the sine is? Do you? Huh? Do you? Do you? Huh? Huh? Well, in case you don't, it's the inverse. So you do sine inverse of this decimal, and you will get b is approximately 44 degrees, 12 minutes. Since we're rounding to the nearest 10 minutes, that's going to be 44 degrees, 10 minutes. So there's capital B. Then the angle C is going to be quite simple because remember the three angles of a triangle must add to 180 degrees. That's 180 for all you Spanish speakers out there. And we'll just subtract that off, and bada boom, you get 84 degrees, 50 minutes. So there it is, it's solved. Again, we started with a side angle side triangle, law of cosines, and we were able to find everything else. Let's look at this one. This is one that's side, side, side. You have all three sides. Now we know we can find the area of that, but how do I find the angles? One tip that I am going to tell you is always start with the smallest angle. If you know that the sides are 10, 12, and 14, you should know that the smallest angle is going to be angle A because it's opposite of the shortest side. So that's the one that I'm going to find first using the law of cosines. So I'm going to plug in the values that I know, and we have to solve for the cosine of A. So 10 squared equals 12 squared plus 14 squared, blah, blah, blah. We know we have to subtract these off, and then we'll divide by whatever that number is. So we end up with 100 equals 144 plus 196 minus 336 cosine of A. Be very careful with your signs on these. So when we subtract off, I can add these two together, but we're going to subtract off 340 from both sides. These two can add together. You cannot add the 336 in with that. That's a different animal because it's a product. So we'll take away the 340. We get negative 240 equals negative 336 cosine of angle A. And when we divide, we end up with 0.7143 is approximately the cosine of A. Now, had I ended up with a number bigger than 1 or smaller than negative 1, I know I did something wrong because cosine has to be between negative 1 and 1. Again, to find the angle, use the inverse. So we're going to take cos inverse of 0.7143, and you end up with 44 degrees, 20 minutes, about. That's angle A. Once we have angle A, it's gravy time because we can use law of sines to find the other angles. And like I said, I go from the smallest angle to the biggest angle. So the next angle I'm going to find is going to be angle B. So I'm going to do little a over sine A equals little b over sine B, because you can have one obtuse angle and that kind of messes everything up with these laws. So if we do this out, let's plug and chug. We got 10 over the sine of 44 degrees 20 minutes equals 12 over the sine of B. Multiply diagonally, divide by the third number, and I put everything in at once and leave the decimal in there. So I get 0.8386 is approximately the sine of B. I do sine inverse of my answer, and I end up with 57 degrees. Angle C is easy. It's gravy because all we have to do is add these two and subtract from 180 to get angle C. So we've got 78 degrees, 40 minutes. Okay, now you have two more examples in your notes, and all they're having you find is a missing side and a missing angle. I want you to do these last two examples on your own. You have to find little c in this first example, and then in the second example you have to find angle C. So I'm going to see if you can do that on your own, and I'll check your notes in class tomorrow. Bye!